Assalamualaikum and hi, my name is Masturina binti Abdullah and today I will be presenting my final year project entitled The Efficacy of Fungi Endophytes of Mentha Piperita origin as Antibacterial Agent. Pathogenic bacteria, especially multi-drug resistant strains like MRSA, remain major public health concern as they resist antibiotics, making infections increasingly difficult to treat. This emphasizes the urgent need for alternative antibacterial solutions. This study focused on Mentha piperita, or known as peppermint, a plant known for its antibacterial properties due to bioactive compounds in its essential oil. In addition to these compounds, the endophytic fungi naturally present in this Mentha piperita plant may also have significant antibacterial potential. However, their effectiveness against multi-drug resistant bacteria, particularly MRSA, is not well being understood. This research evaluates the antibacterial activity of endophytic fungi from Mentha piperita, aiming to address this gap in knowledge and contribute to the development of new antimicrobial treatments. There are two objectives of this study, which are to determine the antibacterial activity of endophytic fungi from Mentha piperita origin against pathogenic bacteria and to evaluate the efficacy of fungi endophytes extract obtained from Mentha piperita as antimicrobial agent. Mentha piperita is a hybrid plant derived from watermint and spearmint. It is widely recognized for its medicinal and industrial applications due to the production of essential oils rich in bioactive compounds such as terpenes, phenolates, and alkaloids. These compounds exhibit antibacterial, antifungal, and antiviral properties, making Mentha piperita a valuable resource in addressing various health concerns. Traditionally, it has been used to treat gastrointestinal issues, colds, and inflammatory conditions, while its essential oils are widely applied in aromatherapy, personal care products, and pharmaceuticals. Endophytic fungi are microorganisms that reside within tissue of host plants, such as Mentha piperita, without causing harm to the host plant. These fungi establish a mutualistic relationship, often enhancing the plant growth, stress tolerance, and defense against pathogens. They are also known to produce secondary metabolites, including bioactive compounds with potential antimicrobial properties. The study utilized several methods to evaluate the antibacterial potential of endophytic fungi from Mentha piperita. Endophytic fungi were cultured and maintained to ensure a consistent supply of viable fungal samples, while test microorganisms, including pathogenic bacteria, were cultured and maintained as targets for antibacterial evaluation. Fermentation and extraction of endophytic fungi were performed to obtain bioactive metabolites potentially responsible for antibacterial activity. The gas diffusion susceptibility assay was conducted in line with the first objective. This method was used as an initial screening method to determine the antibacterial activity of the extracts by measuring the size of inhibition zones around the disc. In addition, minimum inhibitory concentration and minimum bactericidal concentration tests were performed to address the second objective. These tests quantify the minimum concentrations required to inhibit bacterial growth and achieve bactericidal effects. Finally, statistical analysis was carried out by using one-way ANOVA to validate the results and assess their significance, ensuring the reliability of the findings. The results from this diffusion assay revealed the ethyl acetate fungal growth extract at concentration of 100 micrograms per ml exhibited strong antibacterial activity, particularly against gram-positive bacteria. The highest inhibition zone was observed for Staphylococcus aureus at 20.3 mm, followed by Bacillus subtilis with the inhibition zone of 20 mm and MRSA at 90 mm. This inhibition zone were larger than those produced by the positive control, which is chloramphenicol. For gram-negative bacteria, the extract showed moderate activity, with Escherichia coli exhibiting the largest inhibition zone at 15.3 mm. However, the extract showed weaker effects against Shigella boydii and Salmonella typhi, with the inhibition zone of 11.3 mm and 13.3 mm respectively. Notably, no inhibition zone was observed against Pseudomonas aeruginosa. This could be attributed to the cell wall structure of gram-negative bacteria, which acts as a barrier to antimicrobial compounds. The lack of inhibition zone for Pseudomonas aeruginosa may be due to its robust resistance mechanisms, such as efflux pump or limited permeability to the extract, which make it highly resistant to many antimicrobial agents. Overall, the results align with the first objective, demonstrating the antibacterial activity of fungal endophytes extract against pathogenic bacteria, particularly gram-positive strains. The results of MIC and MBC assay align with the second objective of the study, which aimed to evaluate the efficacy of fungal endophyte extract obtained from Mentha Piperita as antibacterial agent. The data in Table 4.2 demonstrate that the extract exhibited both bactericidal and bacteriostatic effects depending on the bacterial strain. For gram-positive bacteria, the extract showed the highest activity against Bacillus cereus, as indicated by identical MIC and MBC values of 1.563 microgram per ml. This strong bactericidal activity may be due to the extract's ability to target the bacterial cell more effectively. Comparatively, Staphylococcus aureus exhibited higher resistance with an MIC of 1.563 microgram per ml and a much higher MBC of 12.5 microgram per ml, with the MBC per MIC ratio of 8, suggesting a bacteriostatic rather than bactericidal effects, possibly due to differences in its resistance mechanism or cellular structure. Among the gram-negative bacteria, Shigella boydi was the most susceptible, with an MIC of 1.563 microgram per ml and MBC of 3.125 microgram per ml, demonstrating bactericidal activity. This could be attributed to the extract's ability to penetrate the outer membrane barrier more effectively in this strain. In contrast, Escherichia coli and Salmonella typhi require higher concentrations of MIC 3.125 microgram per ml and MBC 6.25 microgram per ml, indicating moderate susceptibility, which might be due to the strongness of the outer membrane structures. In conclusion, this study demonstrated that ethyl acetate fungal growth extract from Mentha Piperita exhibited strong antibacterial activity, particularly against gram-positive bacteria. The MIC and MBC tests confirmed the extract's bactericidal and bacteriostatic effects, with Bacillus cereus being the most susceptible, while the extract showed moderate activity against gram-negative bacteria. It was less effective against Pseudomonas aeruginosa due to its resistant mechanisms. It is recommended to further explore this study by conducting a time-kill assay, identifying fungal species, examining structural degeneration, analyzing phytochemicals, and investigating the mechanism of action to gain deeper insights into the observed antimicrobial properties.